So this lesson is on completing the square and looking at completing the square as a means to write the vertex form of an equation and then finding the min and max. So what we're looking for is we're going to look for the min and max through completing the square. So we want to take this equation right here, the f of x equals x squared plus 4x minus 12. And we want to think about this as if it's a zero. For just the time being, 0 equals x squared plus 4x minus 12. So if we were completing the square, we'd move c to the side, add 12 to both sides, and 12 equals x squared plus 4x. Then we make this a perfect trinomial square. So remember, we take b, we would divide it by 2, and square it. So that would be 4 divided by 2 is 2. 2 times 2 is 4. So that's what we would add to both sides. So we do 4 plus 12 on this side. And then we would do x squared plus 4x plus 4 on this side. And then from here, what we're going to do is we're going to actually simplify this. So then 4 plus 12 is 16 equals, we're going to factor on this side. So x plus 2, because we made it a perfect trinomial squared. And now we're going to move this 16 back over, so we'd subtract 16 from both sides. And so my f of x would equal this x plus 2 squared, and then don't forget we had to subtract that 16. So now it looks like it's in vertex form, which means I could easily find the vertex to be the inside opposite. So that would be negative 2, comma, the outside number, negative 16. So if you look at this and think about it, a is a positive 1. So if a is a positive 1, it does make like that smiley face, which means this would have a minimum value. So the minimum value would then be the minimum y value here of negative 16. Sometimes it gets a little tricky because we've got to worry about a number where a is something other than 1. So here's what you're going to do. Essentially, you are going to factor that 2 out of the equation. So I'm going to take the 2 out of the equation, and I'm going to rewrite the whole thing. So f of x, and I really should use the square bracket here, f of x equals x squared plus 6x plus 4 when we factor it out. So we could just distribute that 2 back out. So what we're going to do then is, again, think of this like it's a 0. So if we had 2 times, this would be like a 0 equals x squared plus 6x plus 4. We're going to subtract 4 from both sides. And so we would have 2 times, subtract 4 from both sides, so negative 4 equals x squared plus 6x. So notice I haven't forgotten about a being 2. I'm really kind of just sticking it to the side, and I'll bring it back later into the problem. But really, I'm working everything else in the inside as if that 2 didn't exist. Now what I'm going to do is I'm going to make this a perfect trinomial square. So I still have that 2 that's just kind of hanging out here. I still have that negative 4 equals x squared plus 6x. So we want to take that b, divide it by 2, and square it. So 6 divided by 2 is 3. 3 times itself is 9. So that's what we want to add to both sides. So we'll add 9 to this side and this side. And we're going to clean it up. So we've got 2 times 9 minus 4 is 5 equals, on this side, remember we would factor, so that would be x plus 3 squared because we made it a perfect trinomial square. Now we're ready to put that 2 back. And that 2 is going to get distributed to everything. So it would get distributed to this 5 here and to this parenthesis here. So 2 times 5 would be 10 equals, then we would have 2 times this x plus 3 squared. Then we would subtract 10 from both sides, so f of x equals 2 times x plus 3 squared, and then when we subtract 10 from both sides, minus 10. And so now we could easily find our vertex here. If we were looking at our vertex, we think inside opposite, so the opposite of 3 would be negative 3, and then we have that negative 10. And so look at the value of a, and the value of a, it's positive, which means what we're going to have again is a minimum value. So what's the minimum value? Well, it's this number right here, negative 10. You could have this where you have to apply it a little bit differently. If you notice here, this is in intercept form or factored form. So the first thing we'd want to do is if we're going to put it in vertex form, we really want to go ahead and multiply it out. So we're going to FOIL. So f of x equals x times x would be x squared. X times 5 would be 5x minus 3x when I multiply these, so that would be a total of 2x. And then negative 3 times 5 would be negative 15. And now we repeat the process. So we would essentially add that 15 to both sides because we would change that to a 0. So we'd have x squared plus 2x equals 15. We'd think, okay, what number could I add to this to make it a perfect trinomial square? So we take b, divide it by 2, and square it. So 2 divided by 2 is 1. 1 times 1 is 1. So that's what we would add to both sides. So we'd add 1 to this side, add 1 to this side. That would give me 16 equals, we FOIL this side, factor this side, x plus 1 squared. And then we would move that 16 by subtracting it. So my f of x is going to equal x plus 1 squared, and then don't forget we had to subtract that 16. So if we were looking, let's say, for like the transformations to the parent function, we would say, okay, well, see, this means that it went to the left 1 and down 16, because we think inside opposite, this is your left-right movement, so left 1 unit, down 16 units.